In this video, we're going to take a look at the graphs of ellipses based on their equation. We're going to start with the equation of ellipse in standard form. We're going to convert that to HK form and then look at all the necessary pieces we need to make the ellipses come about. And all this is going to be done using the Desmos calculator. You have access to this link, so feel free to follow along as I do the problems here. So you can see that we've started off with an ellipse in standard form here. Our first job will be to take that and convert it to HK form. And HK form will allow us to find all these nice pieces. The center, we'll find 4 endpoints. We'll talk about the major and the minor axes, and we'll also find those foci as well. So we have a lot of different jobs here to do today. And the worst of the jobs is really converting standard form to HK form. But if you're good at completing the square, it's not that bad. I have the equation all set to go here on Smart Notebook, so you feel free to follow along and write this down as I do the work here. So really what I need to do is I need to split this up. I have 2 terms with x's in them, 2 terms with y's in them, and I have to complete the square for each. So here first, I'm going to factor out a 4, and I have 4x squared minus 4x. And then here with the y's, I can factor out a 9. And I have 9 times y squared plus 2y. And I'm leaving some space because I know I'm going to have to complete the square eventually. And this minus 119 that does not seem so promising right now, we're going to add that to the other side, and we'll see what happens with that. Hopefully something nice will happen at the end here. So now I'm all set to complete the square. X squared minus 4x I know will become x minus 2 squared. I still have this 4 hanging out. But the key part here is this means that I will have a plus 4 in this position, and I have to really think about what's being added here. This plus 4 is getting multiplied by a 4, so it really has the net effect of a 16 on this side of the equation. So I have to add 16 to the other side of the equation. So you do have to be careful there. Same deal over here. Y squared plus 2y, I know that that will be y plus 1 squared. I still have this 9 here, plus 9. This means a plus 1 will get added here, but I really have to think about what the net effect of that 1 is. It's really a 1 times 9. That's 9. I have to add 9 to the other side. So my equation is starting to take shape here. I've completed the square. I have to think about what's on the right-hand side. And this does not look real promising, but it does actually add up to 144. And that's nice because that's a perfect square, and that's going to play into what we do here. Now keep in mind that an equation of an ellipse in its HK form has to say equals 1. And that can be done here by dividing both sides by 144. So a little division is going to come into play here. And this looks like it's going to make things worse, but actually some nice things are going to happen here. If I take this piece and I divide it by 144, I'll be left with x minus 2 squared. And you can verify this comes out as 36 in the denominator, 4 over 144. I also have to do that here, divide this term by 144, and I'll have y plus 1 squared over, and again, verified, that comes out as 16. So something that looked pretty nasty actually comes out quite nicely when we're done. And if we go back to Desmos, you can see I have it set up here. There's our standard form. That is the same thing I have in HK form. So our goal is to try to graph that. So now we're going to go through all the pieces. Well, just like we had with circles and parabolas, once we have it in this form, the center is very easy to find here. In fact, it's all set to go. I can open the folder up, and I notice that the center is the point 2, negative 1, which has now been graphed where it's supposed to go. Okay? Now, what you want to focus your eyes in on next are these denominators. I have 2 denominators here, 36 and 16. And they control the width and the height of this ellipse. And one of them is a squared and one is b squared. The larger is a squared. So I have a squared here, and I have b squared here. And here the fact that a squared is bigger than b squared tells me that this will be a sideways ellipse. This will be one that has more of a horizontal look than a vertical look. And the square root of those numbers, a squared and b squared, they tell you from the center how far out this parabola goes up and down and sideways. And those will help us find our 4 endpoints. So I have a lot of things going on here. Let me get rid of this ink layer. Move this up a little bit so we can kind of see what's going on here. So keep in mind that the square root of 36 is 6. That means from 2, negative 1, if I go 6 in both directions, so 2 plus 6, negative 1, and 2 minus 6, negative 1. Those will be the 2 endpoints. And let me go ahead and activate those so you can see them on the graph. And you can see both endpoints are finally there. Okay. And of course, those points are 8, -1, and -4, -1. They've now been plotted. Same deal in the other direction. I want to take this other number, 16. The square root of that is 4. If I go 4 up and down from my center. So you notice what I've done here is I've gone 4 up and down from my center. And those will be telling me the top and bottom points. And you can see now, hopefully on the graph, that I have the 4 endpoints of my ellipse, and it's starting to take shape here. Okay, let's turn off a lot of this stuff here so we can see what's going on. Let's close up the endpoints. So keep the center there, though. Now the major axis is the longer of the two axes here, and that is the horizontal axis. So the major axis, you can see here, it's really going to be at the line y equals -1. It's the horizontal line, and I have it here all activated. So you can see it. And it has a length of 12. And the reason how I know it has a length of 12 is, keep in mind, from the center in both directions, it travels 6. It's 6 in both directions. It's 6 from here to here, and it's 6 from here to here. So therefore, it has a length altogether of 12. And notice how I did this here, just a little Desmos tip. I used y equals -1, and I restricted the domain to just between -4 here and 8 here. So that's how I got that to happen. So there's our major axis. Again, let's get rid of some ink here, or else it gets really cluttered after a while. Same deal with the minor axis. The minor axis will be the up and down axis. It will be on this line right here. And this is the the vertical line, x equals 2. But again, we don't need the whole line. We just need a piece of it. So I've restricted its range. And the minor axis has a length of 8. So we'll go ahead and activate that as well. And you can see that. So now it's really starting to take shape here. And I dotted them because they're not actually points on the ellipse. They're just helping us define what the lines of symmetry are. So the major axis and the minor axis. The last piece to this is the foci. Now the foci, you have to keep in mind a squared and b squared again. I have a squared, and 16 is my b squared. The rule for foci is as follows. It is that c squared, which will be the location of the foci, or it will help us get it, comes from a squared minus b squared. And this is one of these things that sounds a little goofy because you've kind of known Pythagorean theorem for a long time. This is just one of those rules you have to remember. C squared will be a squared minus b squared. Okay? And that means that c squared here equals 36 minus 16. That's 20. That's c squared. That means, therefore, that c equals root 20. And what that means is, from the center on the major axis, I need to travel root 20 in each direction. And that will tell me where the foci of this ellipse will be. Keep in mind that root 20, I'm not quite sure exactly how much it is. I know it's 4 point something. It's not as high as 5. That would be the square root of 25. So I'm going to use these foci, and I'm going to go ahead and plot them between 4 and 5 away. And again, let's get rid of some of the ink, perhaps. Well, let's see if we can do it without getting rid of the ink. So I had those all set to go here. Yeah, that's going to mess up a lot of things. Well, I think we can deal with it. So I have 2 plus root 20. -1, and 2 minus root 20, -1. I would encourage you to have a calculator out and figure out those values. But again, I know that root 20 is 4 point decimal stuff. So I'm really adding 4 point something to both of the points here. And I can activate these guys, and they're all set to go. And you can see where my foci appeared here. Again, let's get rid of the ink here. Now you can see my foci here and here. So really, the job is pretty much done here. The only thing that's left to do is to actually graph the ellipse. You can see how it's already taken shape. I can graph the ellipse by going back here and just now activating it, and it looks good. So a lot of things we have to do. Turn to HK form, find that center, find the endpoints, the major axis, the minor axis, and the foci.